Now computing limits. Now, yesterday we started with the computing limits, and we say that if we have to start to, in this lesson, we learn how can we solve the limits but algebraically without graphing like the previous one. In the first lesson, we find the value of the limits or evaluate the limits by look at the graph. In this lesson, by evaluating the value of x in the limits. So we will start with the simple, as we said yesterday, then we will go to the complicated one. Now, I will repeat quickly, but you have a video that I recorded from the lesson yesterday. Now, here, if you have limit k, as you see here, if you have now limit for when x approaches to 2, or limit for when x approaches to 1. If x approaches to any number, and I'm talking about a constant 4, like when you say f of x equal 4. So if I ask you about f of 2, you tell me 4. And if I ask you f of 0.1, you tell me also 4, because the function is constant. And here is the same. As limit of 4, when x approaches 2, it will be 4. And here also it will be 4. So limit any constant when x approaches to any number is that constant. But if you have variable x, you have to evaluate the value of x. When I told you that x approaches to, you have to evaluate x at the numbers of, or at the value of x, I told you that it approaches to. Like, if I told you x approaches to 1, you have to evaluate 1. If I told you x approaches to 3, you have to evaluate the 3. Like here, if I told you that f of x is equal to x. So f of 2, it will be 2. And f of 3, it will be 3. So limit f of x, limit x. When x approaches to 2, you say 2. Just evaluate 2 instead of x. And if it approaches to 3, you have to say 3. If it approaches to negative 3, you have to say also negative 3. But limit 1 over x, I'm talking for limit of the reciprocal function. Limit 1 over x, when x approaches to 0 from the left, x approaches 0 from the left, look at the left side. Where's the curve bounded to be? It's going to the next negative y-axis, so it's negative 20. And because it goes to the positive y-axis, if I'm talking about 0 from the right, so it will be positive 20. Sorry, girls, I repeated it quickly because I said it, or I classified it yesterday. I have a video and I sent it to you on WhatsApp. Now here, we say it, okay. Look at this one now here. If you have now, like we said, how can we make a new functions from old? We say that if you have f of x, if you have f of x plus g of x, or f of, what it was, sorry. If you have limit f of x plus g of x Now, the limit of the addition or of the adding is the adding or this addition of the limits. So just like I distribute the limit on the both functions. So I can rewrite it as limit f of x plus limit g of x. Just distribute the limit on it. Then, since x is approaches to 0 as an example, you have to put here also the zeros. And also, if you have subtract, you do the same. You say limit f of x, just you distribute the limits on it. So it will be limit f of x minus limit g of x. And if you multiply them or divide them, you will do the same. And the last one here, if you put the f of x, or sorry, limit the square root of n of x, you can put like this. And you keep the square root outside. So the limit of sum is the sum of the limits, and of difference is the difference of the limits. The limits of a product is a product of the limits, and the limits of a quotient is the quotient of the limits. So as you see here, look how can we deal now with limits. If you have limit f of x minus g of x plus 2h of x when x approaches a. Now, but before that, sorry. Here, I forgot to tell you something, but I said, I think yesterday, if you have limit constant 4 times f of x when x approaches 2, you just drop out the constant outside. Then you would say that limit f of x when x approaches 2. So if you see, a limit that they are multiplied with a variable, you can drop out the limit outside. Then it will be 4 limit f of x. So back here. Let's continue here. So I will distribute the limit on each fraction. Each function. Limit f of x when x approaches a minus limit g of x when x approaches a plus, here we have 2 limit h of x when x approaches to a. Why we put 2? I drop it outside because it's a constant. So if you have a constant, just drop it outside. Why? Because the limit of constant is that constant. So no need to evaluate the limit of it. And if you have limit x cubed as an example, you can rewrite it as limit x cubed x approaches to 2. These are some strategies of the limit. Let's do now number 1. If you know that, limit f of x when x approaches a is 2. And limit g of x when x approaches a is 4. And limit h of x when x approaches a is 0. I want you now to find limit of a plus 2g of x when x approaches a. I just now distribute the limit on it. So limit f of x plus limit 2g of x when x approaches a, Then after that, limit f of x when x approaches a is equal to what? 2 plus. Here we have 2 which are constant, so I can drop it outside. It can be written as a. So it will be 2 times, what is the value of limit g of x? It's negative 4, as you see here. As you see here. So it is 2 plus 2 times negative 4 is negative 8, and the answer now is negative 6. So A now is negative 6. Let's now do B. In B now, I want to find limit h of x minus 3 g of x plus 1. When x approaches a, I will rewrite it as limit h of x when x approaches a minus 3. I will drop the 3 outside. Limit g of x when x approaches a plus limit 1 when x approaches to a. Then after that now, when x approaches a is equal what? It is 0 minus 3 times limit g of x when x approaches a, it is negative 4 plus limit till 1, limit any constant is that constant, which is 1. So it will be negative 3 minus negative 3 times negative 4 is 12 plus 1 is 13. So the answer here now is 13. Let's do C now. Limit h of x minus 3 g of x plus 1 when x approaches to a. Let's choose Dana.
Yes.
Yes, Dana. Can you help me to solve this one?
اوكي. أول شيء
طب يلا please Dana, take 1 minute and I will write back. ايه يلا فكري فيها شوي. Yes.
إنه أحل سي ولا بي؟ لأنك حاطة سي وبس كاتبة سؤال بي.
Yes, Dana. Limit f of x times g of x. How can you solve it?
اوكي بنحط اللي هو 2 times negative 4.
So first step you have to distribute limit f of x into x over a, x approaches a, sorry, and limit g of x when x approaches a also. Because the limit of the product is the product of the limit. Then limit f of x when x approaches a equals what?
2.
2, thank you. And limit g of x when x approaches a
negative 4.
negative 4, thank you. And the answer will be
negative
8. Thank you. Hannah, where's Hannah?
I'm sorry أنا فاتتني حتة عشان الفيديو كان قطع عندي. Can you repeat what Dana said?
Okay, can you help me to solve D? Yes, Hannah, can you?
I will
Hannah?
try, teacher.
Yeah, D now.
Can you hear me?
Limit g of x squared when x approaches a is equal to what?
It will be equal g of x squared.
It will be limit g of x squared, thank you. And limit g of x when x approaches to a is equal?
Equal negative 4.
Negative 4. Then squared, because you have here, it's raised to 2.
16.
It will be 16, thank you. Thank you, Hannah. Darien?
Yes, teacher.
Yes, Darien, I want you to help me to solve E.
Okay. It's the limit of the square root, the cubic root of 6 plus 2.
Yes, okay. You can say it as you want to evaluate shortly.
Yeah.
Okay, so you want to write it as the cube root of 6 plus 2.
Plus 2, which is 8, which is equal to 2.
Thank you.
You're welcome.
Sima.
Yes, teacher.
I want you now to help me with F.
Okay. Limit 2 over minus 4.
2 over, أيوة, which equal?
1 over negative 2.
Thank you.
Welcome.
Now, here now we want to deal with the limits of polynomials and rational function. Let's start with the polynomial. Now, here, if you want to do it in a longest way, you have to say that its limit x squared over x minus, when x approaches to 5, minus limit 4x when x approaches to 5, plus limit 3 when x approaches to 5. Then you will say 5 squared, just evaluate the value of x in x squared, minus 4 times 5, because it's limit x, plus 3. Then you will say 25 minus 20 plus 3, which is 8. This is a longest way. Now, Today, I will tell you now a shortest way without using or without doing all these steps. You have to do like this. Limit x squared minus 4x plus 3 because all of the polynomial function is approaches to 5, so I can just evaluate 5 in the function. So it will be 25 minus 20 plus 3, which equal to 8. This is for the polynomial functions. This is the same as if I told you that f of x is x squared minus 4x plus 3. I told you to find f of 5. You do the same steps. But here in limit, you will do the same steps. But I mean that if limit of this curve or of this polynomial function, the number is approaches to be 8. Let's do now the rational function. For the rational function, you will do the same. It will be limit 5. It's like 5 times 2 cubed plus 4 over 2 minus 3. 2 cubed is 8 times 5 is 40 plus 4 is 44 over negative 1, and the answer is negative 44. Now, by now, as you see from here, this one here, the limit was limit 5x cubed plus 4 over x minus 3 when x approaches to 2. So what are the zeros? Oh, sorry, what is the zero of the denominator? Did you remember in grade 10 when I told you in chapter 8 in the rational functions that the restrictions, or you have to find the zeros of the rational expression, and the zeros of this rational expression, the values is not defined because it's put here 3 minus 3, and I mean that these functions are defined in all values except x equal 3. Why? Because it is the zero of the denominator. Is it right? When you want to solve it. Now, here x is equal or is approaches to 2. It's not to 3. So I can evaluate the number. Later on, if we find like 5x cubed plus 4 over x minus 2, and I told you that x is approaches to 2, and if you put here, evaluate 2 down, minus 2, the answer is 0, which is undefined. Okay, right now, okay, forget this thing, it's early now. Tomorrow, inshallah, when we talk about it, I will tell you about it. So if you have now a rational expression for this one, you want to use the CMS, just evaluate the value of x, if it is polynomial or rational functions. Let's do now number 3. In number 3 here you have limit x times x minus 1 times x plus 1 when x approaches to 2. I just evaluate the value of 2. Yes, yeah, Lulu. Lulu. Lulu,
أيوة ماس.
can you help me to solve number 3? Yes, tell me. 2 minus 1. Thank you. 2 plus 1. Okay, so 2 times 1 is 2, times 3 is 6. Thank you. Let's do number 4 now. Its limit, x cubed minus 3x squared plus 9x when x approaches to 3. Let's ask Malak, where are you?
Yes, teacher.
Yes, Malak. Yeah.
3 cube, which is 27.
Okay, 3 cubed minus
Minus
3 times 3 squared
3 plus 9 3 times 3.
times 3. 3 cubed is what?
27.
27 minus 3
27.
squared.
3 squared 9 times 3.
27 plus
27.
27, and the answer
27.
27. Thank you. Now let's do the last one. Who want to help me?
Me.
Yes, Lana. يلا. Limit x cubed plus x squared plus x to the power 101 when x approaches to negative 1.
It will be negative 1 cubed plus negative 1 squared plus negative 1 to the power of
Raised to the power. Thank you. Negative 1 cubed.
1 لا negative 1 برضو.
أيوه. Plus
1
plus 1 plus
negative 1.
negative 1. 1 negative 1 plus 1.
Negative 1.
No, 0. Okay, the answer is negative 1. Thank you. Now, negative 1 raised to the power 101 is what? Is positive or negative 1?
Negative 1.
Thank you, because 101 is an odd number, so the answer is negative 1. Thank you, Lana.
Thank you.
Okay, by now I will stop our lesson. Tomorrow, inshallah, we will talk about the rational expression, but with more complicated one. Thank you for listening. Do you have any question?
No, thank you,
Thank
teacher.
you.
Okay.
Thank you, teacher.
No, thank you, teacher.
Thank you. Thank you
Bye.
for listening. Bye-bye. Bye.
Bye.